These are problems for 10.3, 10.4. Since chord CB is equal to chord CD, it means that their two arc angles are equal. So it means that this arc angle is also going to be x degrees. Then if we look at the entire circle, we know that x plus 64 is equal to 360. So subtract 64 from both sides, divide by 2. We get that x equals 148. All right, next one we have GH perpendicular to AE, so a right angle, and B and D are the centers of the two circles. And then since AC is equal to 26, we see that AC is a diameter, which means that every radius of circle B is going to be 13. So AB is 13, BG is 13, BC is 13. And also, we're told that DE is equal to 15, which means that from point B to point D, we have a length of 15. We can get into that a little bit more later. GH is 24. So since this chord is 24 and it's perpendicular to a diameter, that means it's also being bisected. 24 divided by 2 means that each of these lengths is going to be 12. And we can use this to start solving some of our problem now. In this triangle, we have a right triangle. If we use Pythagorean theorem, this length comes out to 5. So from B to that point is 5. The entire length of BC is a radius, so 13 minus 5 means that this much of the segment is going to be 8. And then as we look at trying to find the length of DC, I know that the entire length of DB is the radius of the circle on the right, so that length's got to be 15. So 15 minus 5 minus 8 means that DC is equal to 2 units. The other length we're asked to find is GC. So now we'll pay attention to this triangle. GC is the hypotenuse of this right triangle, so 8 squared plus 12 squared equals GC squared. And then if we solve that and simplify it down, GC is equal to 4 root 13 units. We're trying to solve for x and y. 105 degrees is an inscribed angle, which means that its corresponding arc angle is twice as big, so x has to be equal to 210. And then going all the way around the circle, 60 plus 210 is 270, which means that if we take 360 minus the 270, we have 90 left over for y. Right, in example 4, we're given two major arcs, LKM and LMK. And one of the things that I noticed is that since LKM is 300, it means that this angle, what's left over, has to be 60 degrees. So then since 60 is the arc angle, its inscribed angle over here must be equal to 30 degrees. Not one of the ones we're looking for, but that is going to help us. From L through M to K, this entire angle is 200 degrees. If this green angle is making up 60, then we could take 200 minus 60 to get to this arc angle is 140 degrees. Wrong angle metric, this should be 220 degrees. So 220 minus that 60 will give us 160 degrees for this yellow. Divide that by 2 and we'll get that y is equal to 80. And then inside of this blue triangle, we have 180 degrees. 180 minus 80 minus 30 gives us 70 for x. And 5x is going to be half of that arc angle. Well, that arc angle is also going to be twice as big as 40. So 40 times 2 makes this 80. 80 divided by 2 gives us that x equals 40. And then going the other way, y is half of that arc angle. Well, 41 is also half of that arc angle, so 41 times 2 is 82. Divided by 2 means that y is also 41. In this one, we have an inscribed quadrilateral, which means that the opposite angles are supplementary. So if we add 2x plus 5 plus the x plus 40, that's going to equal to 180. And then if we do all the algebra on that, we'll get that x equals 45. And once you know that x equals 45, you can plug that in, which makes this angle more specifically 55 degrees. And then we have y plus 55 equals 180. Solve for y, you get y equals 125. Number 7, we're given a few lengths. The most important one is that CB equals 12. Diameter is 12, so the radius is 6. This length is 6. OB is 6. And since AB was given to be 12, 6 minus 2 means that that length is 4. If we draw in that radius, it also has to have a length of 6. It creates this nice right triangle. 4 squared plus x squared is equal to 6 squared. So that x squared equals 36 minus 16 or 20. So x is equal to 2 root 5. And then rs would have to double it since the diameter is perpendicular to the chord. These two segments are equal to each other. It makes the whole length 4 root 5. Problem number 8. We're given the 140 and 62 degrees. Since this arc angle is 140, that means the central angle, angle 4, is also going to be 140 degrees. Inside of this triangle, we know the three angles add up to 180. Also, since the radius is equal to this radius, we know it's an isosceles triangle, so this angle 5 would also be equal to that angle. So 140 plus angle 5 plus angle 5 equals 180. So if we solve that for angle 5, then we get 20 degrees for angle 5. Going around the middle of this circle, if we took 360 minus the 140 minus the 62, it turns out this angle is 158 degrees. We have another isosceles triangle. Angles 3 and 1 have to be equal to each other. So 180 equals measure of angle 3 plus measure of angle 1 plus 158. And again, since those two are equal to each other, we're going to have angle 3 plus angle 3 plus 158 equals 180. And when you solve that, you'll get the angle 3 and angle 1 are both going to be 11 degrees. And lastly, we have this other isosceles triangle. Angle 2 is equal to the angle over there. So angle 2 plus 62 equals 180. And when you solve that for angle 2, you'll get 59 degrees. Number 9, we have two variables. We have an inscribed quadrilateral. We know that the opposite angles are supplementary, so we can say that 3x plus y minus 40 is equal to 180. So there's one of our equations. The other thing we know is that this inscribed angle 4x is going to be 1/2 the corresponding arc angle. So we could say that 4x is 1/2 of 2y plus 10. Now if we simplify this, that gives us 4x equals y plus 5. Now you have two equations, two unknowns, so you can solve it with a system of equations, either elimination or substitution. You will be getting fraction answers. I'm not going to do all the algebra, but I will tell you that x equals 225 over 7 and y equals 865 over 7. Number 10 is one of the hardest ones to see. It says from point Q an arc is drawn through point P. In other words, this arc is the start of a circle that would look like this. The radius of that circle is QP, which is also the same radius as circle P. So these two segments are equal to each other. This segment is also equal to those. And QB and PB are also the same. In other words, we have these two equilateral triangles. And you know that in an equilateral triangle, all the angles are 60 degrees. Now with these numbers, I'll look at the question. The measure of arc angle AQB. A Q to B, what is this arc angle? We'll bring it back to its central angle. 60 plus 60, so this angle is going to be 120 degrees. Since this arc angle, central angle is 120, this arc angle is 120. We have circle P and circle Q, which means P is the center of the circle on the left, Q is the center of the circle on the right. So if I draw in that segment, that's a radius of circle P. And if I draw in that segment, it's the radius of circle Q. And since the circles are congruent, those two segments are going to be congruent to each other. What I'm going to do is insert a temporary variable and call this little length x. Now, if you look at this yellow triangle with this light blue triangle, I know they're congruent to each other, and the radii have to be congruent. They share this side. It's right triangle, so by HL, those triangles are congruent, which means that that length is also going to be x. And the reason why that's going to be really significant is as we focus more back on this triangle, the length of xy is 8. This segment is perpendicular to a diameter, so which means it's split up into a 4 and a 4. And in this triangle, we have a length of x, a length of 4, and then the hypotenuse is the radius. The radius would be that length, circle P. So from center P to a point on the circle, that distance is x plus 1. So this length is 2x plus 1. Now in that yellow triangle, Pythagorean theorem, we get this equation. X squared plus 16 is equal to 4x squared, 4x plus 1. The quadratic, so the whole left side equal to 0. 3x squared plus 4x minus 15. This will then factor as 3x minus 5 times x plus 3. So x equals 5/3 of negative 3. Negative 3 doesn't make sense, so x equals 5/3. PQ is 2 of those x's, so 5/3 plus 5/3 gives us 10/3 units.